For more information on tutoring or how to support Moof University and the production of more videos, please visit moofuniversity.com. Thank you and enjoy. Next is positron emission, or beta plus emission. A beta plus particle, or a positron, is represented like this. Pretty much the opposite of an electron, right? So instead of a -1 for the z value, it's got a 1, and it's got a positive charge. So it can be represented in any of these ways with the beta plus, or just the beta, or the E plus, or just the E, but as long as the Z is +1. Sometimes people put the plus sign in front of the 1. I'm not really a fan of doing that. So a positron is the antiparticle of an electron. Okay, so just the opposite of it. Okay, so let's do this example. Carbon 11 is the parent here. We've got a mass number of 11, a Z of 6. That means that the N will be 11 minus 6, which is 5. And the positron over here has an A of 0 and a Z of 1. And so its N is 0. Okay. Now, what's going to happen as far as the daughter? Well, let's just balance it, right? If the A over here on the left side is 11, over here the A from the beta positive particle, the positron, is 0. So the A here in the daughter is going to be 11. What is the Z going to be? Well, it's 6 over here, and it's 1 right here, so it's got 1 plus 5 is equal to 6. So we got 11 as the mass number and 5 as the atomic number, so we've got boron. If you look on the periodic table for the number 5, the atomic number 5, you'll find B, which is boron. Okay. So the N value there, 11 minus 5, is 6. Okay. So let's think about how these values change. The mass number stays the same. Because we went from 11 to 11. The Z went from 6 to 5, so it decreased by 1. And the N went from 5 to 6, so that increased by 1. This is pretty much the opposite, as far as the Z and N go. This is the opposite of the beta minus decay, right? Here it's the same as the beta minus decay, right? The beta minus particle did not affect the mass number. It affected the Z and the N. Here it's the same, but the results, as far as Z and N go, are the opposite. Okay, and so the general form can be written like this. The A stays the same, Z decreases by 1, and I'll put a little cloudy box around that, or a little cloud. So why does this happen? When would this occur? Well, positron, oops, that's supposed to be a plus sign there, it looks like a minus. Positron emission occurs when there are too few neutrons. So this is basically the opposite situation as far as beta minus decay goes, right? In beta minus decay, there were too many neutrons. Now there are too few. So in this case, what happens, this converts a proton into a neutron and a positron. Okay, so proton turns into a neutron and a positron. So if we show that with the notation here, right? 1, 1, 1, 0, 0, 1. Up here, the mass numbers 1 and 0 add up to equal 1, and the Z's add up to equal 1. So this checks out as well. So in this case, since there are too few neutrons, it takes a proton and turns it into a neutron and a beta plus particle that's emitted. Okay. So the opposite effects, essentially, of beta minus decay. So I hope that video was helpful. Thank you for watching. If you found that video helpful, don't forget to like, comment, subscribe, and share with friends. Thank you, and happy studying.